question 2. In this question, I squared is equal to -1. The complex numbers Z1, Z2, Z3 are shown on the Argon diagram below. One of these numbers is on the imaginary axis. So we have our diagram here. Here we have Z1, Z2 and Z3. Using the Argon diagram, write down the values of Z1, Z2 and Z3 in the form A plus BI, where A and B are elements of Z. Okay, so Z1 is out here, so that's going to be 4 plus 3i. Let's write that in, 4 plus 3i. Z2 is here, and that's going to be 0 plus 2i. And Z3 then is out here, that's -2 minus 1i. That's it for part 1. Let's have a look at part 2. Write down the value of the modulus of Z2. So the modulus of Z2 is going to be the modulus of 0 plus 2i. What that involves then is taking the square root of a squared plus b squared. So our a is 0, we've got to square it. Our b is 2, which we've got to square. So 0 squared is 0, 2 squared is 4, the square root of 4 is just 2. So the modulus of Z2 is just 2. Okay, let's look at the next one. So in this case we have v is 15 over 1 plus 2i, write v in the form a plus bi. So this is taking 15 and dividing it by a complex number, 1 plus 2i. So what you need to do here is multiply by the denominator's conjugate, the conjugate over itself. The conjugate is 1 minus 2i. So you divide that by 1 minus 2i as well. So 1 minus 2i divided by 1 minus 2i is just 1. So all we're really doing here is just taking 1 and multiplying it by this fraction. So if you multiply any fraction or anything by 1, you're not going to change it. So we haven't changed the fraction here, but it will help us get rid of that fraction, if you like, and rewrite it in the form a plus bi. So if we multiply the top by the top, the bottom by the bottom. So 15 times 1 is 15. 15 times minus 2 is minus 30. And then we're going to divide that by 1 times 1 is 1. 1 times minus 2i, minus 2i. Plus 2i times 1 is plus 2i. And then plus 2i times minus 2i. Well, plus times minus is minus. 2 times 2, 4. I times I squared. So let's just simplify this. We've got a 15 minus 30i. Got to divide that by 1 minus 2i plus 2i will give us 0. Now remember, I squared is minus 1, so minus 1 times minus 4 is plus 4. So that'll leave us with 15 minus 30i divided by 5. I'll just come over here. You must divide the 5 into both of these because the two terms on top are separated by a plus or a minus. So 5 into 15, 3, 5 into 30, 6i. And that's it for part B, 3 minus 6i. Let's have a look at part C. The complex number w is 1 plus 2i, and it's shown in the diagram below, drawn to scale. Let's see, the three complex numbers labelled a, b and c are also shown on the Argon diagram. One of these is w with a bar over the top, the complex conjugate of w. So I guess they're asking us which one is it. So our complex number is w, it's here. The conjugate of that is going to be this one here, it's going to be c. Because if you take a complex number, if you take any complex number, a plus bi, the conjugate of a plus bi is a minus bi. So our answer was C, and the complex number itself was, what was it, 1 plus 2i. So the complex conjugate of 1 plus 2i is 1 minus 2i, which is, if you like, the image of W under axial symmetry. under axial symmetry in the x-axis. So when you have a complex number, any complex number, its conjugate is going to be that complex number reflected in the x-axis, or in this case I should really say the real axis. So when you have any complex number like w here, its conjugate, its complex conjugate, is going to be the image of that complex number under axial symmetry in the real axis. So I should really say, rather than the x-axis here, I'm going to say the real axis. Okay, and that's it for question 2.